Solving systems by substitution. So we don't have any new vocabulary. This isn't a new problem. We are still solving a system of linear equations, but in this case we're going to be using a different method. We're going to be using substitution to solve it rather than graphing. Okay? Keep in mind we're still finding the solution that satisfies both equations. Okay? If this is my system, these are my two linear equations. I'm looking for the x and y value that's a solution to this, as well as a solution to this equation. Okay? When we're graphing, it's where they cross. Okay? Still the same thing. Basically, what we're doing is we are saying, okay, if I'm looking for the values that satisfy both, or that are solutions to both of these equations, they're going to be the same values. Okay, so this y is going to be equal to this y, and this x by itself is going to be equal to this x. Okay, so what I'm going to do is I'm going to kind of combine them. Okay, I'm going to say if this y, which is the same as this y, if this y is equal to 3x, and this y is equal to x plus 8, I can substitute for either one of these. I'll say I'm going to substitute for this one. I'm going to still have my equals 3x, but I'm going to substitute, instead of having y, I'm going to say that y is equal to x plus 8, so that x plus 8 is equal to 3x. Okay? And having done that, now I can easily say, all right, I've got an equation, it's just one variable, I can solve for that. Right? Subtract x, 8 equals 2x, or 4 equals x. Okay? All right, once I've got my first variable, I'm going to go back into either one of the equations, doesn't really matter which one, but I'm going to go back into one of them, and I'm going to substitute the value I've figured out to figure out my other variable. So I'll use this one, y equals x plus 8, but I already know that x is 4, so y equals 4 plus 8, or y equals 12. Oops. Y equals 12. And if I had used this equation, we can see that I would have gotten the same thing. I would have had y equals 3x, 3 times 4 is 12, y equals 12. Okay? Both of these equations are in our slope-intercept form. Okay? This one happens to be a direct variation equation. But even if they're not, if they start with your x variables isolated, you can do that as well. You can start by figuring out your y. You can say that x is equal to 1/2 y plus 5, and x is equal to negative 4y plus 1. So I should be able to say that 1/2 y plus 5 is equal to negative 4y plus 1. And that's fine, right? I still got one variable. I can solve that for y and then go back to figure out x. Okay? Don't let the fractions scare you too much. You can figure those out in the same way you would a normal single variable equation, multiplying by everything by the denominator, or you can just figure it out and add your variables, okay, and add your fractions. All right. Most often when we're solving these problems, we are going to have equations that are not already isolated, where our variables aren't already isolated. And that's kind of our first step, is to isolate those variables. Okay? I have made a list of steps that we can kind of help follow. They can help us, but systems of equations have a number of different ways to solve them, and a number of different ways for most of these steps to go through them. So although the steps can help, it's better to understand the process we're going through and leave the steps for later. Okay? So I have my two linear equations. I am going to want to isolate a variable. Okay, I could choose x or I could choose y. In this case, because I've got a y here by itself, I'm going to start with y because that's going to be the easier one to isolate. So I have this one. I'm going to isolate y by subtracting 2x from both sides. So I'll have y equals negative 2x plus 6. Okay, and then this one, I've already got y by itself on one side, but I'm going to need to isolate it by dividing everything by 3. That'll cancel, and I'll have y equal to 9 over 3, or 3x, minus 12 over 3, or 4. Okay. Now, after that step, I've got my variables isolated. Okay. Then I'm going to combine them. Okay, I'm going to substitute. So y is equal to 3x minus 4, and y is equal to negative 2x plus 6, or 3x minus 4 is equal to negative 2x plus 6. Okay, and I'll solve that. I'll add 2x since this is the smaller one, so I'll keep my terms positive. And in the same step, I'm going to kind of jump ahead. I'm going to add 4 to both sides. All right, nothing wrong with combining like that. 3x plus 2x, 5x equals 6 plus 4, 10. Divide by 5, divide by 5. X equals 2. Okay, now I've solved for my variable. I'm going to substitute my value back into one of my original equations. Okay, doesn't have to be one of these before I simplified. In fact, it's probably easier not to go all the way back, but choose one of the ones where you have the variable isolated. Okay, so one of these two equations are the one I'm going to use. Looks to me like this one's probably going to be easier to use since I don't have a negative there. So I'm going to have y is equal to 3 times x, which in this case is 2, minus 4. 3 times 2 is 6, minus 4 is 2, y is equal to 2. Okay, and then I've got my answer. So the solution to both these equations is 2